Hello and welcome back. This will be the second video on section 4.3 and this video will feature conditional probability. And we've already seen this a little bit, but we'll go maybe into a little bit more detail in this video. So conditional probability is the probability of an event given extra information about what has already happened. So the probability that an event may occur may change if you're given some extra information on things that have already occurred in the past. So the probability is conditional on an outside event. So for instance, like in the last video, if you draw a card from the deck, there will be a certain probability that the card will be a heart. But if you're told that someone has already drawn a heart out of the deck, now the probability has changed for you to draw a heart out of the deck. Now there's fewer hearts left in the deck. So given extra information about something, you can change probabilities. So for instance here, the probability of this is the red is the probability of B given A, and it's that order. This is B given A is the probability that B will occur given that A has already occurred. So we're given some information about the past. Now we saw with the multiplication rule that when we want to find the probability that two events happen, so if it's A and B, we know that we're going to be multiplying. So the probability that A and B occur is going to be the probability that A occurs times the probability that B occurs. But when we're trying to figure out what the probability that B occurs is, we already have some information. We already know that A had to have occurred by the time we got to B. So one way to think about this is A occurs first and then B. So the probability that A occurs and then B, well, we have some extra information and we need to take that into account. So this is the multiplication rule, and one thing that we can do is we can solve for the probability of B given A. The probability of B given A is equal to the probability of A and B divided by the probability of A, just dividing both sides by this. Now, this is a perfectly valid formula to use. It's generally hard because oftentimes this is going to be a little bit hard to calculate, and an intuitive approach is almost always going to be easier. So know this formula, but the intuitive approach is going to be what we'll use most of the time. So here's an example of just some numbers I've made up. We'll pretend that we've run a medical trial to test test some new medicine to see if it works, and we have a group of people that we actually gave the medicine, and we have a group of people that we gave the placebo to, and then we recorded if they improved or if they didn't improve. So here we're asking, what is the probability that a person's health improved given they received medicine? So we are told, so we want to calculate whether or not, calculate the probability that a person's health improved, but we're given some information. We're told that they received medicine. So in our study, we know that we're only concerned with this information. In this question, we are given some information that the person that we're looking at was given medicine. So they weren't given placebo, so we're just going to ignore these numbers for now. So given that they received medicine, what's the probability that they improved? So we would write this as the probability that they improved given they received medicine. So again, to calculate a probability, given everything is equal, what we want is the total number of ways that we could randomly select someone who improved. Well, there's 106 people that improved, and we want to divide by the total number of people, and in this case we're only worried about the total number of people that received medicine because this is information that we're told. So the total number of people that received medicine is going to be 106 plus 34. When we add this up, this will be 106 divided by 140, which is approximately 0.757. So given that someone received medicine, there was a 75% chance that they improved. And this is how to interpret this probability. We can also do this in reverse. We could say, what is the probability that someone was given medicine given that they improved? As in, what's the probability that someone received medicine given that they improved? So now if we come back to our little chart here, we are told that someone improved. This is information that we are told. So we are only concerned with these numbers. And in fact, these ones we can ignore for the moment. So here, we're told that someone improved, even though I've used the word given here. So what's the probability that someone was given medicine given that they improved? So we want to count how many people improved on medicine versus how many people improved overall. So again, there were 106 people that improved versus the 106 people that improved on medicine and the 71 people that improved on the placebo. So this is going to be 106 out of 177, which I calculated earlier to be about 0.599. So when we look at this again, you're given some information. You are given that we can assume some information. So up here we assumed that the persons we were looking at were given medicine. Here we assumed that the persons we were looking at improved, and then we wanted to calculate, did they receive medicine or did they improve? These guys look very similar. So you could ask, is the probability of A given B the same thing as probability of B given A? Well, clearly these two numbers aren't equal. So these are not going to be equal in general. They could be equal by a random happenstance. It could just be random luck that they are equal. But in general, these are not equal. This is a very, very common mistake. So it is very important that you know the order in which these go. This is the probability of A given B. And as long as you know this order, these sorts of questions should be relatively straightforward. And please, I'll just remind you, please reach out if you have questions. I know probabilities can be a little bit tough at times, so please reach out, send me an email. There are other tutors on campus that will be willing to help as well. So if you need help, it is available.